Hi everyone. Okay, so this is notes 5.1 day 2, and this is part 2 of the notes. So here for number 8, go ahead and take a look. For cotangent x times cos squared of x equals cotangent of x, what you want to do is you want to go ahead and solve this, but you want to get 0 on one side. You want to go ahead and subtract cotangent of x from both sides of the equation, because if you divide, you don't ever want to divide by a trig function, you'll end up losing some of your answers, and you'll see at the end how that would have been a mistake. So if we factor out a cotangent, and now because of the zero product property, we know that the cotangent of x equals 0, or cosine squared x minus 1 equals 0. So we have cosine squared x equals 1, so we know cosine is plus or minus 1, cosine x is positive or negative, and cotangent x is 0. So what's very important is for us to think about our domain of our function. Notice that you're looking for values of x that make the cosine of x 0, but not the sine of x. You can't divide by 0. So very important for our domain. The sine of x cannot be 0. So the cosine is 0 at pi over 2 and 3 pi over 2. But notice we want to know when the cosine of x is positive or negative 1. But again, the sine of x cannot be 0. So those answers are not part of our solution set. So for part A, you would say x equals pi over 2, or x equals 3 pi over 2. All right, so now for part B, notice I want all solutions. I want find all solutions in radians. So you would say, well, let's see. I could say pi over 2 plus pi k. K is an integer. You also could have described those solutions by saying pi over 2 plus 2 pi k and 3 pi over 2 plus 2 pi k. That would also work. This way is more concise. All right, let's go ahead and do one more problem, and then the rest you can finish for homework. So if you take a look at number 9, notice we have a problem with sine and cosine in the same problem. That makes it difficult. So we'd like to either have them all be cosines or all be sines to try and factor. Again, I think we could think of our Pythagorean identity to help us here. So the sine we're stuck with, but we could replace cosine squared with 1 minus sine squared of x. So now we would have 2 times 1 minus sine squared plus 3 sine x equals 0. So we have 2 minus 2 sine squared x plus 3 sine x equals 0. I think it might be easier to factor this if our leading coefficient was not negative. So we'll do 2 sine squared x minus 3 sine x minus 2. I went ahead and multiplied both sides of the equation by negative 1. So now there are a couple ways you could do it. You could just jump in and factor, or you might want to do some type of substitution to help your eyes a little bit. You might say, well, if the sine of x is u, we have 2u squared minus 3u minus 2 equals 0. And then you can go ahead and factor it. All right, so let's see, that worked out. So now we know that u is negative 1/2 or u is 2. But again, the u was sine x. So again, you might not have had to use the substitution. Some people don't. Some people could just factor right away. Now, the sine of x has a range of negative 1 to 1. So we know that those solutions are extraneous. But the sine of x is negative 1/2. There you go. When x, here, let's see, part A. When x is 7 pi over 6 and 11 pi over 6. And then for part B, if I'm asking you to solve, find all solutions in radians, you could say 7 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k, where k is an integer. Nice job, everybody. Go ahead and finish the rest for homework.